All right, hey everybody, I'm Jared, and like you said, I'm going to be talking about the physics of scale model roller coasters. Now, to begin on a personal note, roller coasters have been my special interest since I was literally 3 years old. So to be here today getting to share my enthusiasm with all of you, I cannot express how meaningful it is. It's awesome. And these are just some of the scale model coasters that I've built over the years. But let's look at a couple in motion, right? That's what they're meant to do. So here I have two examples. The one on top was built using the Coaster Dynamics model system, and on the bottom, it was custom built using 3D printed parts. Now, looking at these for a little while, let me ask, does anything look kind of odd to you guys? Well, if you're thinking what I'm thinking, they don't look real, because the model trains are moving way too fast, right? It looks ridiculous that you could imagine if a full-size roller coaster looked like this, it would be insane, and also the G-forces would kill everyone on board, but that's beside the point. But let's do a direct comparison to be sure. So here we are looking at Hyperion. It is one of the tallest and fastest roller coasters in Europe. That's the real footage on the left, not a model. There it is reaching 90 miles per hour. Now, let's compare it against a 1/40th scale model on the right. Okay, so there's clearly a discrepancy here between the apparent speeds of the real coaster and the model. And for a lot of people, this induces a sort of cognitive dissonance where they look at a model and they go, something doesn't look right, it moves way too fast, I don't understand. And all over the internet, there are comments from people expressing their confusion, their frustration, not understanding the physics. What's going on? Why is it like this? Well, the problem lies with gravity. Both the real coaster and the model are subject to the same gravitational acceleration. You can't scale down gravity for your model. So, for example, as both trains are falling down their first drop, they will both fall their first meter, for example, in the same amount of time. But for the model, 1 meter is already half of its entire height, whereas it's almost nothing for the full-size coaster. So that's why this discrepancy occurs. But the question is, people want to know, how can we fix it? How can we make a model coaster that looks real in lieu of being able to scale gravity? So more specifically, how do we slow down the model coaster train? Well, people have offered plenty of ideas. One common suggestion is to add weight to the train, but this won't do anything because gravity affects all objects equally regardless of mass. So that does nothing. Another idea is to add friction, and sure, friction would slow down the model train, but it would do so non-conservatively. The train would lose all of its momentum, and it wouldn't be able to make its way through the layout. Third idea is interesting. It says, motorize the model train. Do away with gravity entirely. And a couple recent projects have managed to achieve this. It's very technically complex. But because motorized models aren't really in the spirit of a gravity-powered model coaster, we'll set this solution aside for our purposes. But by far the most popular idea, which some of you may have thought of already, and it'll be the remaining focus of this talk, is let's just watch a video of the model in slow motion, right? So here are a couple comments from online that suggest that very thing. And they say, oh, play it at half speed, quarter speed. But it's apparent based on these comments that people are just guessing an appropriate playback rate based on what feels right. And sure enough, this happens a lot. So I wondered, is there a mathematically precise way to choose a slow motion playback rate so that when you watch a video of a model at that rate, it looks real? The motion matches how it would look as a full-size coaster. What do we think? Can it be done? Will it work? Yes, the answer is actually yes, it does work. And now I'll share with you my approach to finding the exact solution. So suppose that on the left we have a full-size segment of track for a coaster. And we say that along the track we have some position x. And for every position along the track, we have a function for the height of the track at that position and a function for the speed or velocity of the train when it is at that position. Similarly, we have a scale model of the full-size coaster, specifically a 1 to sigma scale model, so like 1 to 40, 1 to 80. And again, for every position along the track, we have a function for the height of the track at that position and the velocity of the train when it is at that position. Now, because one is a scale model of the other, we can establish by construction this linear relationship between the two height functions. We also suppose that the full-size coaster has some initial velocity when the train is at the beginning of the segment, And then we're going to have to choose what the appropriate initial velocity is for the model. So what is our goal? Specifically, we want to choose a slow motion playback rate r and an initial speed for the model v0, so that when we watch footage of the model in slow motion at the rate r, the motion matches the full-size coaster. And that is captured by this equation relating the two velocity functions. The approach that we're going to use is conservation of energy. So we're going to assume that energy losses to friction, air resistance, and vibration are negligible. You might remember from physics class that we can characterize the energy of the coaster train by its kinetic energy due to its velocity and its potential energy due to its height. And because we're assuming conservation of energy, no matter what position, any position x that the train is at, we can say that it is equal to the initial energy of the train. And we can achieve a similar equation for the model. Now, with this system of four equations, there is only one possible solution for r and v0. It's very easy to derive, so I won't go through the details here. But what we find is that the playback rate r has to be 1 over root sigma, and the initial speed v0 has to be 1 over root sigma times the initial speed of the full-size coaster. So note, we don't scale down the initial speed linearly for the model. We scale it down by 1 over root sigma. Let's put this to the test with a simulation. So there are a couple roller coaster design tools out there, but none of them could do what I needed. So I actually created my own simulation software that allowed me to arbitrarily scale down a coaster to make one that's a scale model of another. So on top, we have a full-size coaster that has an initial speed of 10 meters per second. On the bottom, we've zoomed in to look at a 1/25th scale model. And based on our solution before, we can derive what the appropriate initial velocity will be. Now, first, let's watch them in real time, and we can expect what we're going to see. So blink and you'll miss it. OK, so as we expect, the model is over before you know it in real time. The full-size coaster is still going. OK, now let's try again, but in slow motion. So we're going to play the footage of the model back at 20% speed, which we find because it is a 1/25th scale model, so 1 over root 25. And sure enough, the motion matches perfectly between the two. OK, simulation's one thing, but let's actually try it on our comparison before. So on the left, we have our real-time footage of Hyperion, the real coaster. And on the right, we have the slow motion of the model at playing at 18% speed. And as you can see, they track with each other pretty nicely. Now, the truth is that with a 1/40th scale model, we would expect the theoretical playback rate to be 16% rather than 18%. And we can account for that, or we can recognize where that error comes from in a couple ways. One, this might not be a perfect 1/40th scale model. The initial speed of the lift hill on the model might not have been appropriate. The energy loss characteristics for a full-size coaster and a model are very different from each other. And we also assumed conservation of energy, so that can make a difference. But what we have done is gotten sort of a first-order approximation. It's only 12% off in this particular case. I think that's pretty good. So a model builder who wants to employ the slow motion approach, we've empowered them. You say, here's the initial speed to use for your lift hill or for your launch, and here is the playback rate to use, and you'll get in the ballpark of what looks right. We've taken the guesswork out. Slow motion is a perfectly viable solution. And just to conclude, I want to thank all of you for listening and indulging in my favorite topic. I hope I've introduced many of you to a medium of art and engineering that maybe you were unfamiliar with before. And of course, I'll happily take any questions or talk about roller coasters in general with anybody who's interested throughout the entire conference. Thank you. Yeah?
It's great, but we can't really slow down our vision to 80%. We live in real time. So in some ways, it's not really a satisfying solution. I'd like it to be a model that I can watch and it looks realistic.
Yes.
Thought, what about the idea that they had from ages on the cars you push on the cars?
I'm so glad you mentioned that. So yeah, the idea, some people have said this online. They say, wait, put like a flywheel into the model train. No, as far as I'm aware, no one's tried it yet. But a couple days ago, I ran the math, and I'm pretty sure, theoretically, that would work. If you had the appropriate sort of radius flywheel with the right gear reduction, that could actually work in real time where you can eliminate slow motion entirely. My guess is that in practice there would be so many energy losses and technical issues. Besides, a flywheel generates torque, so that might actually mess with how the model train goes through its layout, but it is a very interesting idea. The other thing I can actually show, I mentioned motorization. These are 2 clips of motorized models, so these are in real time, and they've eliminated gravity entirely, and that's actually pretty interesting. Now, like I said, it's a little bit different from being truly gravity powered. A flywheel or something along those lines might be a better solution to satisfy the people who say, no, roller coasters have to use gravity. But yeah, there's a lot of interesting ideas going on. I mean, these sort of innovations, both of these models are 3D printed too. A lot of these innovations in the model coaster space have only been in the past like 5 years. So there's a lot of really interesting innovation going on. Yeah?
So your roller coasters are on wheels and they're actually rolling.
Yes.
Correct? Right, they're not sliding. And your equations are for a sliding object.
Yes.
And so 2 comments. One is your 12% discrepancy, I don't know the numbers work out right, but you're getting this kinetic energy going into the wheels.
Absolutely.
So you lose it. So there's a shift going on there. But it also strikes me that by changing the moment of inertia of the wheels, you could control the speed. And I don't know whether you could do it in a way that would slow it down.
Right.
Flywheel thing, just have the wheels themselves. I mean, maybe you have to make them out of platinum and change the whatever it is.
Yeah.
But it'd be interesting to see if you could control the speed with that.
Yes. So it gets very so indeed, like, who needs a flywheel? You already have wheels. They already have a little rotational inertia. That's true on a real roller coaster and on a model coaster. My guess is that it's pretty negligible compared to the overall linear kinetic energy. It's the other challenge with that is that it's already really hard to design model coasters that have the right tolerances and everything, even just with regular little ball bearings and whatever. So to try to introduce, my guess is that in the real world, to try to introduce that sort of component of inertia in the wheels would already be overcomplicating something that's already actually very hard to achieve.
My guess would also be that in the real world, to get the slowdown you want with normal materials would not be doable.
Probably not, yeah.
It's interesting to see just, is it even, like, mathematically does it scale?
Yeah, absolutely.
Can you set it up to scale?
Absolutely. Yep.
What would you recommend as a toy brand for a kid getting into a roller coaster?
Yeah, so I can show here. So my go-to for years and years has been K'NEX, K-N-E-X. That's what those in the middle are made of. Also the model of Hyperion, that enormous 7-foot tall model, was also built with K'NEX. So you can make some really big, impressive models with that. Yeah, that's the standard. Lego also has some models, but they skew towards more like being stylistic than being realistic. The most realistic off the shelf is Coaster Dynamics, which I showed towards the beginning. Those are much more of a specialty model, though. Yeah?
So at the beginning you said we couldn't control for gravity, so that's why we're slowing it down. So have you ever, I mean, we slowed it down, but assuming we looked at it and it wasn't slowed down, presumably you could calculate what gravity is, right? If you assumed you were going at the speed.
You're saying if you watched and back calculated what gravity would yield a certain motion characteristic?
Yeah, I mean, instead of saying it's in slow motion, you could also describe it as a gravity simulator.
Oh, sure, absolutely. And people also joke about like, oh, once we get to the moon, we'll be able to put a model coaster on the moon and that'll have different. Yeah, you could totally say like, here's a model of what a coaster would look like on Jupiter or whatever. Yeah, absolutely.
Put it in an accelerating elevator.
Yes.
No.
Yeah.
If it's in free fall, nothing's going to happen.
Yes.
Get an accelerating elevator the right way, you scale it.
Yes, you could totally put it in an elevator or a artificial gravity ring or something, and that could achieve a similar effect. But I'm guessing that's a couple years away from the coaster community. But yes, absolutely. All right. Thank you.